I have about a 4-slide lesson for you today, and then after that's over, I'll have some time to talk about some problems from the homework. And then if we have time left, I have your text to pass back and we can go over those. So, let's start with this. Let's start with this. All right, let me walk up here. Solve that, please. If you learned anything yesterday. Whatever method you want. If you want to multiply it out, great. If you want to use product rule, great. I would probably suggest that you use product rule just so that you can practice the product rule. But one of the great things that makes this such a great country is that you can do whatever you want, like Paul right on. Make sure you keep your notation clean. If you're going to multiply it out, then you call that f of x until you actually take the derivative, which then becomes f prime of x. Don't get lazy.
Product rule or multiplying it out? Looks like product rule.
Cool. All right, excellent. Great. Yeah. Good. Good. Yeah.
Product rule? Yeah. Cool. Product rule around? What are you doing? Anybody multiplying it around? Multiplying it out? You got it.
You get same? Pretty good possibility that you got it. What about this one? Same? Yes. No. Yes.
I don't know how I.
There's only one question. There you go. That's something different. Uh-oh.
It's like
Same?
1 over 1 instead of like over 1 or less than 1 is
Same.
It was like
Same. 36x squared minus 22x minus 25. See? It seems you have just taken the product rule, put it in a headlock, and made it your own. Excellent. So, today I got 2 quick things to talk about, one of which we talked about yesterday, so it won't be a big deal, but the other one you're going to love. Yeah, it's Trig. Yay, Trig. So, I'm going to break this into 2 parts. One part is going to be for those of you that want a little background information and want to know where these come from. The second part will be for all you memorizers out there. So trying to appease both crowds. Okay, so how would you find a derivative of tangent? Other than memorizing what the answer is. Say what? You You just firing off things?
She's just messing around.
Ideas?
Oh, there's like a
Would you break it up to sign over cosine?
There's like what?
You do all of that.
You do all of that. I can't really see what that is. I have old eyes.
It's a lot of work, you know what I mean?
Oh, it's easy. It's not that bad.
No, I don't know. It looks not fun.
Do you, yes?
Would you like split it into sine x over cosine x and then do quotient?
Let's give it up, yo. Nicely done. Kaboom. Tangent is sine over cosine. Now, why am I doing this? Because I think it's important that you understand where it comes from instead of just memorizing. So, if on a test or a quiz you happen to forget what the tangent derivative is, you can always figure it out by using this method. So, using the quotient rule there, we get that mess. Ooh, and that's scary. Okay, but that's all of the stuff you need. Denominator on the bottom squared, bring the denominator up to the top, times the derivative of the numerator, minus big honking brackets, the numerator times the derivative of the denominator, pregunta. Ash, what's better?
Do you, when you like do all of this, you have to write the like d over dx, you just do like f of x, like f.
That's the proper notation when you're given the function. You could have just said, well, f of x is tangent of x, and then said f prime is equal to. Yeah. And I don't, what am I trying to say? You probably don't need this step because you know what the derivative of sine is, yes? What's a derivative of sine? Cosine. And what's a derivative of cosine? Negative sine. So we do a little bit of magic there and we get that. Ooh, you remember that. What's cosine squared plus sine squared? 1. So we get 1 over cosine squared, which is secant squared. Yep, it's just that cool. So suppose you wanted to figure out the derivative of cotangent. Patricia, how would you do it?
The other way around.
The other way around.
So if it, yeah, it's cosine over sine x.
Cosine over sine, do the same thing, correct. How about the secant?
But you can say it's cosine over what?
And I'm,
Would it be cosine squared?
hold on, back up. How would you take how would you take the derivative of secant? What's secant
I
equal
thought
to?
you were doing cotangent.
No. Just do it. Secant. What's the secant equal to? Not what's the derivative, just what's the secant equal to?
Oh, 1 over cosine.
1 over cosine, and then do quotient rule again. Right? Cosecant is 1 over sine, right? It is 1 over sine. Use the quotient rule. Cotangent is cosine over sine. And when you do all that fun stuff, you end up with that. So there's your chart for the memorizers in the crowd. Whoop, whoop. Memorizers, come on now. I will give you one tidbit of information that might help. Notice that if you're taking the derivative of a trig function that starts with the letter C, as in cat, your answer will be negative. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. The derivative of cosine is negative sine. Got them all? Good? Okay, we talked about this yesterday, so I'll go through it quickly. Because yesterday, many of you, in fact, all of you told me that you would be able to do that, right? If you can take a first derivative, can't you take a derivative of a derivative and get the second derivative? And the third, and the fourth, and the nth term. All that chart is just different ways to represent the same thing. Most commonly, we're going to use the first two columns. Y prime, Y double prime, Y triple prime, Y to the fourth prime, or Y quadruple prime, etc., etc. or we'll do the f primes. Occasionally you'll see the third column. Most definitely, that was horrible. The fourth and fifth column you probably won't see. Okay, so make sure that in this case, I don't know why people do this, but they always confuse this as d cubed times y over dx cubed. It's the third derivative. Has nothing to do with cubing. Any problems? You can handle that, right? Beautiful. We're done. That's it. I told you it was quick. So we're going to stop here.